Hello everyone, welcome back. This is the fourth video in the playlist where I will be talking about the various machine learning algorithms that one must know to work as a data scientist. In my previous videos, I have talked about the programming language and the core concepts around programming language that one should know. And then I spoke about the statistics and probability concept that one should know before going ahead with the machine learning algorithms. So make sure you have watched the previous two videos before watching this video further. Although a new machine learning models or architectures are arising day in and day out, but no matter what, the classical models architectures are the foundation. So in order to advance or in order to learn even the new concepts that are arising in deep learning, you must have a good foundation about the classical machine learning models. So here are the list of the classical machine learning models that and what you should know about them specifically. That's what I'm going to continue talking in this video. Starting with linear regression. Linear regression is one of the simplest modeling technique that we have or modeling algorithm, and you must know about it thoroughly. And yeah, it's always not expected because hardly any data set nowadays is so simple to work with linear regression. But again, there are a lot of the concepts, a lot of the foundations that have come out of linear regression that those are still being used even for the advanced level of architectures like deep learning architecture. So starting with linear regression will always give you understanding of many ML concepts and the should be useful for you. So whenever you go ahead and start learning for linear regression, make sure you look for the answer to the questions like why linear regression is called linear. That's a valid question, although nobody thinks about it. Why it's called linear? Why can't we say non-linear? Is it just randomly the name is taken or chosen, or there is some logic behind it? So you should must know this difference why it's called linear. How are optimal parameters computed in linear regression and multivariate regression? So linear regression is, or whether you talk about multivariate regression, they, if you know, in any machine learning model, and especially for the supervised machine learning model, this is one of the supervised machine learning models. There is one training phase and then we have prediction phase. So in the training phase, you learn the parameters, model parameters. And in the prediction phase, you make use of those parameters to predict the value. So the question here is how it's being computed. So make sure because you complete your statistics and probability before going through these topics, because a lot of these answers will be statistical, connected to stats. That's why you will not be able to understand if you don't understand stats. So to give you an example, linear regression. In linear regression, the parameters are computed via maximum likelihood estimation and the least likelihood estimation. So these are two different concepts that's used to come up with the optimal values. Now, these optimal values are not the exact solution, but they are the estimated solution. So these are basically estimated out. Then you must also learn about the assumptions of linear regression. In other words, if I say you, how can we connect the assumptions with the statistics? Yeah, that intuition you should have. And why these assumptions are even important. If you Google, you'll get a list of the assumptions for linear regression. So just don't try to memorize as it is, but try to understand what they exactly mean. What happens if they are violated? Why they are even important? Which aspect of the stats they are connected to? How should you improve on that? There are various research going around to improve them, to overcome them. So can you do any contribution to that? Can you come up with any new ideas to improve them? That what your concept should be while we are learning them. Again, you should know about the advantages and disadvantages of linear regression. So every model that we are going to talk here will have some sort of advantage and disadvantage in terms of a lot of ways, like in terms of computation time, in terms of simplicity. For example, linear regression has an advantage of simplicity. It is one of the simplest models that we ever have in history of prediction. So it's very easy to learn, it takes very less time for training. But the disadvantage is that it cannot work with huge data. Okay, and it fails to even perform better when your data has a lot of non-linearity, and if your variables are not non-uniform nature. Now these terms might be sounding familiar to you. Yeah, these are from your statistics, non-linear, okay, and then non-normality. If you heard of Gaussian distribution, so it is believed that the features or the variables that we pass through linear regression should have uniform distribution. Sorry, it's not uniform, it's normal distribution or Gaussian distribution, and they should be linear in nature. Now, what is the definition of linear? If you are not sure, then you can go back and revise your correlation concept, scatter plot concept, that will give you an idea of about the linear relationship. Then limitations. What are the limitations? So when I say limitations, it's from technical point of view, and of course statistical point of view indirectly. So what are the limitations of linear regression? In other way, I'm asking you, can you use linear regression always on every data? uh, and if yes, then, or if no, that you have to decide. So you should be thorough with minimum these questions answers whenever you talk about linear regression. Although it's optional that you really want to learn the mathematical equations of a linear regression, it's mathematical form. That is totally optional. Nobody will ask you until you are applying for core research field. But if you're just applying for a job profile, knowing the overall concept, intuitions, that's more than sufficient. Let's go to the next one. That's called logistic regression. Again, for logistic regression, you should know its working, how it works, how this is different from linear regression, why it is called logistic regression, and what are the assumptions again to be made to work with logistic regression. What happens if you violate any of the assumptions? Are there any key assumptions and then minor assumptions, major assumptions, any concept like that? Again, what are the advantages, disadvantages, and limitations working with logistic regression? What happens? And again, what is a sigmoid function? Very important. What does sigmoid function do? What is odd? What is logit? These are few concepts related to logistic regression, although but mostly it goes ahead with even to deep learning. So in deep learning later you'll get to know, especially in the whenever you have a deep learning for classification model, this concept will be valid there too. What is a sigmoid function? What is it? So this is one of the mathematical function that has certain shape and attributes, and that helps to basically transform infinite minus infinity to plus infinity between on the scale of 0 to 1. Now what is this scale or transformation between 0 to 1? So that if you know about probability, then you know a probability can be between 0 to 1. So in a way, logic and odd or sigmoid function, this all concept put together helps you to transform linear value from minus infinity to plus infinity to on the scale of 0 to 1, or in terms of probability score. So yeah, you should know all this. And of course, what happens we do that? Why should we do that? Can we skip that? What if you don't skip that? So if you can understand all this intuition, that's what is required from interview perspective. Well, let's go ahead with the random forest. Random forest. Okay, so again, it's working, how a random forest work, its architecture, if you know, well and good. And then you should also know about the various core concepts related to random forest, like Gini gain index. What is Gini gain index? How to compute that, if you know, well and good, that's an extra thing. Sampling with replacement. Random forest works with something called sampling with replacement. So what happens in sampling with replacement? What will happen if you replace this concept with sampling without replacement? That you can develop. So once you read about it, you'll get to know all the insights. So you try to analyze things in that direction. Bootstrapping aggregation, or also called bagging. So that is a core feature of random forest and so in bagging, what happens, how it works, what it does, what problem it solves. If you can answer, that's what it's expected. Then how does a random forest handles high variance? Firstly, you should know what is high variance, what it indicates, what problem random forest is actually solving. And this all, if you understand all this, then you know what random forest is doing when it's handling high variance. Also, why random forest is called random forest? What is so randomness about it? How random forest achieves that randomness? And this is one of the very favorite interview questions by the interviewer. Why random forest is called random, or how randomness is achieved in a random forest? And yeah, think about it. I can give you a hint here, but again, I would like you to think about it or read about it, and then because the answer is here on the screen itself, but yeah, I want you to find out. Then again, once you are clear about the core working of random forest, then you can, again, you have to think in terms of advantages, disadvantages, and limitation of random forest. Can you use random forest always? What are the scenario you can use? What are the scenario you cannot use? As an example, I'll give you a hint. See, if the variables are highly correlated, it's believed that your random forest will not perform well. Okay, so that's one of the limitations of random forest. It expects the variables to be least correlated or null correlated. That's the limitation. And again, advantages is that random forest is very much good for handling non-linear data. And the disadvantage is that the random forest is highly unstable model. What do you mean by highly unstable model? That you can again read on about it, but these are the few properties of random forest. Let's see the next model, that is gradient boosting algorithm. Now again, this is, if you understand this algorithm, you are going to do a lot good while learning for deep learning. So deep learning has a lot more information taken combined from random forest and gradient boosting. So learn about it. So again, what is boosting in gradient boosting algorithm? How does it work? You have to get answer for it. What problem is being solved by boosting? What it's solving? Why we are even worried about this boosting? What will happen if you don't have boosting concept? And how do we achieve that boosting? What is gradient descent approach? What happens in gradient descent? That's what you should learn. But again, I would say at this point it would be optional. But if you learn, well and good, because as I said, these few concepts are taken carried forward even to the deep learning. So it will help you there if you learn it here. Then advantages and disadvantages, and again limitations of gradient boosting algorithm. So you have to learn these questions. Coming back to support vector machine, again working of a support vector machine, how it works. What are support vectors in SVM? Why they are called support vectors? What happens? What they do behind the scene? If you can narrate that, well and good. What are kernels in SVM? Again, the kernel concept in what we have in deep learning, that's taken from SVM. So what are kernels? What type of kernels we have? Few example you can give, like no, we have uh, uh, we have linear kernels, we have non-linear kernels, we have RVS kernels. So various types are there, and you can even read about individual if you're interested, but not mandatory, how they work and how they are different. But again, you understand the limitation of support vector machine is that choosing the right kernel is must. And SVM, it does not do on its own. As a data scientist, we should know which is the right kernel for the given data set. So If you don't have a right data kernel taken for the given data set, SVM can perform very bad. Okay, so now the question is when to use SVM. Should we use SVM always on every type of data set or any specific type? What will happen if you use SVM on every type of data set? Well, if you when you'll read about it, you'll get to know SVM is a very computationally expensive model to train. It takes a lot of time for SVM training, but it can perform well if you have only taken right kernels for the given data set. If you don't choose the right kernels, it's likely that you will end up getting very poor performance with SVM. So that's the reason you should know about the kernels. You should know which kernel to pick at what point of time. Otherwise, you'll get a very bad performance after waiting for several days of training. That's the reason we go with SVM. And likewise, you have to talk about the advantages, disadvantages, limitations. I already told you the disadvantage with SVM is it's computationally expensive. Okay, and of course advantage is it can work and it can provide you a really good accuracy or metrics, given that you choose the right kernel for your data. And the limitation is for SVM that you should know what kernel to be used. If you are selecting a non-linear kernel for a linear data, obviously the result will be very poor. So choosing a right kernel is very important. And given this all broadly, if you know this classical models working well and the questions we discussed thoroughly, if you can answer to anybody, that's what expected by your interviewer or in industry. And because these are the foundational concepts and knowing these concepts can help you understand the even advanced concepts. So I hope this video is helpful to you. I will come up with the next video on the various data science and machine learning concepts, core concepts. Until then, you have a happy learning.